Okay, hi, a very good day to everyone. Today we're going to enter AMath chapter 7. And chapter 7 we're going to talk a little bit more about coordinate geometry. Okay, so what is coordinate geometry again? It is actually to look at shapes, to look at the properties of points, lines, and so on, with the help of a coordinate system. Right, so these are some of the background knowledge that we need from AMath, right, and lower sec. So the first one over here, point number 1, is that now the first knowledge that we need about is points, right? And points is usually expressed in a coordinate. So a single point carry one pair of coordinates x and y. Alright, then we extend this to lines, okay? And the line is actually a collection of many points. Alright, so one more time here. So we have one point in just a single x and y, and lines is actually a collection of points x, y. Now because there is a collection of points x, y, this set of x, y form a relationship y equals to mx plus c. One more time, because lines is a collection of points x and y, and so this set of x and y's will form the relationship y equals to mx plus c. So this equation of the line over here represents all the possible points that form a line, right? So this is why we call the equation of the line, or the name of the line, right? Then because of equations, we have two elements to the equation. We have the gradient, and we also have the y-intercept, right? So gradient y2 minus y1 over x2 minus x1, or the change in y over change in x. Now then equation of the line, y equals to mx plus c. So as you can see over here, we have the y-intercept at this point, we have the x-intercept at this point for this line, and we take these 2 points, right? In order to find the gradient, we need 2 points, okay? And whenever we want to find equation of line, we need one gradient and 1 point to find the equation of line. Then point 3, we're going to look at the distance between 2 points, where the distance between x1, y1 and x2, y2 will be using the Pythagorean theorem, right? The extension of the Pythagorean theorem on coordinate systems, right? So you've got the change in y, change in x to give you the diagonal. Okay, so with this, let's move on to 7.1. Now in 7.1, we will talk a bit about parallel lines, and under parallel lines, we got two big concepts. First concept is to talk about the angle of inclination. So over here, the first idea that we need is actually gradient as a measure of steepness, or the rate of change of y against x. Okay, and with this, we have the first set of information that we need to look at over here, right? So first and foremost, we need to take a look at the left set and the right set. So on the left, you have your lines L1 and L2. For the right set, you have your lines L3 and L4. Now, as you can see, L1 and L2, they are parallel. L3, L4, they are also parallel. Okay, so over here, the first idea, before we talk about them being parallel, let's talk about the angle of inclination. So what is the angle of inclination? It is the angle of the line measured anti-clockwise from the positive direction of x-axis. So for example, we have the positive direction of x-axis over here. So I will need to measure based on this special line over here, okay, the angle to the line. So the angle will be the anti-clockwise angle from the horizontal direction in the positive direction of x-axis. So this angle over here is our angle of inclination. Now in the same way, for L2, over here is actually the positive direction of x-axis. So based on this line over here, the angle of inclination will be over here like this. Now, what about line 3 and line 4? Now same thing, we're going to take the positive direction of x-axis as the reference, and here we will take the anti-clockwise angle, and we call this the angle of inclination. Then in the same way for L4, positive direction of x-axis, then the angle from this direction we put here. Now what do we mean by this? Let's say if we go to the negative direction of x-axis, the angle that we will look at is this one over here, right? To look clockwise from the negative direction, which is not what we want actually, right? We always refer to the positive direction of x-axis for angle of inclination. The reason why we do this is by convention, so that we can actually do this for the future. Now, so over here we have the first concept over here. If you can look at this triangle over here, okay. Now over here, based on this angle, we actually can draw a right angle triangle from this angle. Now from this right angle triangle, opposite the angle, we label this O. Adjacent to the angle, we label this A. The hypotenuse will be over here, right? Now, so which one is actually our gradient? So our gradient is actually our change in y, right? Change in y over your change in x. So the opposite or the adjacent, which one shows us the change in the y direction? So it's actually the opposite, and the adjacent shows us the change in x. So it will be opposite over adjacent. So which trigonometric trigo links opposite to adjacent? Your tangent. So tangent of the theta, which is the angle of inclination, will be equals to opposite over adjacent, which is equals to the change in y over change in x. So the final result that we were looking at is that the tangent theta represents the gradient of the line. So if we were to look for the angle of inclination, we will need to do the inverse tangent to find out the angle of inclination. So this is our first result over here. So without further ado, let's take a look at try 1, okay, page 158, and let us look at this information over here. Okay, so we find the acute angle that the line segment joining P and Q makes with the positive direction of the x-axis. So what do we do over here? Now, having this as a tool, we don't really need to draw a diagram or to imagine, but on your own, you should be imagining what's going on. Okay, so let's try and see. So let's do this blindly first, and let's check with the drawing after this to see whether did we do right or wrong. So the results over here is tangent theta equals to gradient. Okay, so what is tangent theta? So tangent theta will be equals to y2, the gradient. So y2 minus y1. So I'm going to take like negative 3 minus 6. Then x2 minus x1, so negative 2 minus 4. So tangent theta is going to be equals to 3 over 2. Now I want the angle of inclination. So angle is equals to inverse tangent of 3 over 2. Okay, so with this, what is this angle? 56.3 degrees to 1 decimal place. Okay, so in order to find the angle again, we look for the inverse tangent of the gradient. Now let's check and draw and check and see whether do we do right or wrong. So P would be, if P is down here, Q is up there actually. So technically speaking, right, we are on the right track, right? We got the correct ratio, we got the correct positive gradient, and the angle that it makes with the positive x direction over here, this angle over here is 56.3 degrees for this line PQ. Okay, now let's move on to the second idea of the day, which is to look at parallel line. Okay, now let's come back to this concept over here based on these two parallel lines again. So over here we can see that L1 and L2 are parallel. So let's write this proof over here. Alright, so we have L1 and L2 which are parallel. So L1 is parallel to L2. Okay, so this would be the result over here. So L1 parallel to L2. So L1, what does it mean? They have the same steepness, okay, as line L2. Okay, so what does this mean? Because they have the same steepness, the angle of inclination of 1 is equals to the angle of inclination of 2. And because they are acute angles, so tangent of angle 1 is equals to the tangent of angle 2. So what does the tangent represent again? The gradient. So gradient 1 will be equals to gradient 2. So the result is, because L1 is parallel to L2, your gradient 1 is equals to gradient 2. Now in the same way, let's look at L3 and L4. So L3 is parallel, so this is a symbol for parallel, yeah. So let's say if L3 is parallel to L4, as you can see over here, which is actually quite clearly, so means that L3 have the same steepness, okay, as L4. So over here, this means that the angle for 3 is equals to the angle of 4 because they have the same obtuse angle. So tangent of angle 3 is equals to tangent of angle 4. And because of tangent represent the gradient, so the gradient of 3 is equals to the gradient of 4. So over here you can see the results where when two lines are parallel, the gradients are the same. So very, very important point. When two lines are parallel, the gradients are the same. So without further ado, let's look at try 2 in page 160. So over here we want to determine whether the lines AB and CD are parallel. Give reasons to support your answer. So whenever we determine whether they are parallel or not, we need to show just now our results from just now. So what do we need to do is to show that the gradients are the same. So show that the gradient are the same, then we can say that they are parallel. Okay, so this would be the logic of our argument. So let's go to part A. Part A, we have 2 points over here, two lines AB and CD. So let's try to find the gradient of AB. So gradient of AB, you notice that I'm not writing gradient, right, of AB, which is a bit long. If you don't mind, if you want it to be clear, it's fine. Okay, my style would be the gradient of line AB. So AB is a subscript over there, is equals to, now we have let me do this nicely. We have a 5 minus 0, so y2 minus y1, x2 minus x1. Okay, so this one is actually equals to 1. And let's check for gradient CD over here. Gradient CD is y2 minus y1, x2 minus x1. So this is actually negative 1. Okay, so the conclusion is, since the gradient of AB is not equal to the gradient of CD, the conclusion over here is that AB is not parallel to CD. Okay, so this is short form that I would like to write. Okay, now let's take a look at part B. We will determine whether is that parallel or not by looking for the gradient. Okay, so B. So we look for gradient AB. So what does gradient AB calculate? We have 4 minus negative 2. At the same time, we also have 4 minus 7. So this will give me negative 2. Okay, so with this, let's take a look at gradient of CD. Gradient of CD is equals to 4 minus 8 whole thing divided by 2 minus 0. So this is also negative 2. So let's write our concluding statement. Now since, because we wanted to show, right? So since the gradient of AB is equals to the gradient of CD, so the two lines AB, right? Therefore AB is parallel to CD, like that. Okay, so here we go. So this is try now, question A and question B. So without further ado, let us take a look at one new skill that we're going to learn today. We're going to look at also the new equation of the line, right? So I'm going to teach you how to find the equation of a straight line. Right, so previously in AMath, we've covered the first method of finding the equation of the line. Okay, so what's the first method of finding equation of a line? It is to do this. So method 1 is to do find the gradient first. Right, find the gradient first. Okay, so whenever you look for equation of a line, right, you need two things, right? So first you are going to need a gradient, okay, and then you're going to need also one point, right? One point that the line passes through. Okay, so for method 1, usually the first step, what we do usually is to find the gradient, and step 2, once you find the gradient, you form y equals to mx plus c, right? Then number 3, you sub in the points, okay, to find point C. And part 4, last but not least, the final equation, okay, y equals to mx plus c. So actually this, right, it actually takes quite a number of steps to finish, right? So this is why I will be teaching you another way, a slightly shorter way to find the equation of a line. So method 2, okay, method 2 is actually to use the formula, right? So let's say if you have a gradient, and you have a point x1 and y1, okay? So what you're going to do is, I'm going to make use of the formula y, okay? So y minus y1 is equals to gradient times x minus x1, okay? Now why does this work? If you see this thing over here, if I were to move x to the denominator, is this m? M equals to y minus y1 over x minus x1, and y and x are the, what do you call this? Y and x are the general variables, and then your y1 and x1 is the point, the coordinate of the point. Okay, so with this, we transform this to this form where it is slightly easier to find our equation of the line. Now, so with this, I'll be using method 2 for this chapter, so hope you can see and follow. Alright, so with this, let us go to exercise 7a. Now over here, we have two lines here. So find the equation of the line passing through point A and parallel to the line L. So over here, we need L, we have L, and we have A. Now the only information is that, okay, before the information, in order to look for the equation of the line, we are going to need gradient first, and we are going to need a point x1 and y1, which we have in this equation. Alright, so we are going to need these two things to form the equation. So with this, right, because they are parallel, because both our lines are parallel, so the gradient we can get from the line L. So from line L, okay, it's good to write down statements because usually this chapter they're working a bit long. So from line L, we have 2x plus y is equals to 3. Sorry, wrong color. Change this to black. Okay. Alright, so from line L, 2x plus y equals to 3. Let me change this into the other form, y equals to mx plus c form. So this is our gradient. So the negative 2 is our gradient. Okay, so over here we can say that the gradient, okay, so gradient is equals to negative 2. Okay, so the equation of the parallel line, okay, so the equation of the parallel line passing through A will be like this. So I'm going to have y minus y1 is equals to the gradient x minus x1. So what is my y1 over here? I'm going to make use of this point. So x1 is 0, y1 is 1. Okay, so over here I'm just going to sub in y1 is 1, I'm going to sub in x1 is 0, and I'm going to sub in m is negative 2. Okay, so let's simplify this. So y minus 1 equals to negative 2x. So y equals to negative 2x plus 1. Okay, so here is either you do this or you can do the y equals mx plus c. You have your m, sub the 0 and 1 to find your c, also can. And you need to restate the equation, also can. Okay, so this is 3a. Okay, so let's take a look at the same thing, which is question B. Alright, so in B we have again two lines. We've got the line L and we've got a point. So we can get the gradient from here, and then we can get the point from here that it passes through, so that we can get the equation of the line. So with this, okay, so first thing I'm going to look for the gradient first. So from line L, right, from line L, I have x plus 3y is equals to 12. So 3y, I'm going to express this into the y equals to mx plus c form, is equals to, okay, it's equals to negative x plus 12. So divide by 3, so I'm going to have negative 1 over 3x, right, divide by 3, and I'm going to have plus 4 divided by 3, right? So with this, the gradient is this one, negative 1.3. So over here, oh my goodness, okay, gradient equals to negative 1.3. So with this, let's take a look at the equation, right, which passes through A. So equation of line through point A. So I'm going to make use of y minus y1 equals to m times of x minus x1. So here is my x1, this one is my y1 over here, right? So x1 is 2, a negative 2, y1 is 0. So let me sub in this point. So x1 is negative 2, y1 is 0. So 0, negative 2, m earlier is negative 1/3. Okay, let's take a look at this. So y is equals to negative 1/3 of x minus, so let's expand. So x plus and minus, so negative 2 over 3. So this is the equation of the line through point A. Now with this in mind, so this is the second type of equation that we can do, which is to use the gradient from another line to find the equation of a new line passing through another point not on the line. Okay, so with this, let's move on to the final bit of concept over here, which is to look at your collinear points. Alright, so for collinear points, we are looking at 3 or more points that lie on the straight line. Okay, so for example, A, B, and C, they all lie on the straight line. So to show the collinearity, to show that it is really collinear, we have two methods in general to show. So over here, method 1, because they lie on the straight line, so this means that they are parallel. So because they are parallel, you can show that they have the same gradient. So you need to show same gradient. So gradient of AB equals to gradient of BC. You can also show that a gradient of AC as well. Okay, but just two of it will do. Alright, then because of that, you're going to mention the common point B. You mention the common point B, or for this case is B. Let's say if you were to use AC, then maybe common point would be another point. Alright, so I would definitely say that the method 1 is better for this case. Right, but let's take a look at method 2 to see how this goes. So method 2 is to look at distances. Okay, method 2 is to look at distances. So for distances, you just need to take the distance, sum up. Okay, and then you need to label the distances accordingly. So maybe AB plus BC is equals to AC. You need to do that first, alright? But the problem is that if you calculate distance, right, you have to use a lot of square root, which is a bit uncomfortable for some people. Okay, now over here, right, for method 1, is it enough to show that just same gradient? Not enough, because when they are same gradient, they are parallel, but they may not lie on the straight line. Okay, so over here you have to also mention the common point B as well. Now in method 2 is the same thing. Even though we don't need to mention common point B, when you state the equation AB plus BC equals something left hand side and right hand side is AC, you already show that there is a common point somewhere. Okay, so with that, we will jump straight into the next part, which is to solve try 3, right? To use 3 different methods to show that PQR are collinear. So once again, I'm going to use the method 1, which is the easier method. Okay, I'm going to show you method 1, which is the easier method over here, which is to show the gradient and state common point, right? So let's show gradient of PQ. So gradient of PQ is 12 minus 2y2 minus y1 x2 minus x1. So this is this will be 5 over 2. Okay, so let's look at gradient of QR. So gradient of QR, I'm going to take R minus Q, so negative 3 minus 2 divided by negative 2 itself. Right, so this is going to be 5 over 2. So the gradients are the same. So since gradient of PQ is equals to the gradient of QR, okay, so being same gradient is not enough, we need to show common point. So which is the common point in our calculation? And Q over here is a common point. So with this, the conclusion is P, Q, and R, they are collinear, or they lie on the straight line in our coordinate system. Now I'm going to write out method 2, but method 2 I will only upload in the note version. Alright, I won't be presenting here because method 1 should be good enough for you to look at points for collinear. So over here, let me show you once again what are we doing here. So over here we did some recap from background knowledge, and we talked about angle of inclination, right? Tangent angle equals to gradient, and because they are parallel, the gradients are the same, the tangents are the same, so the gradients are the same. So when you have two parallel lines, the gradient are the same. So this is the highlight of this part. And with that, I went through 2 more concepts. First concept, equation of a line, where we explore the alternative equation of the line. So method 1 is our standard method, find gradient y equals mx plus c, subpoint, final equation. Method 2 is to use a new formula. So y minus y1 equals to m times x minus x1. And with this, we need gradient, we need 1 point. Now, next, we also looked at collinear. So what it means to be collinear, when 3 or more points on a straight line is you need the same gradient, and to state the common point in your explanation, like this question over here. So this ends today's lesson. Hope you had a good time, and see you next week in class.